All right, let's get right into it. This is a pretty incredible story. It's about how a freestyle rapper's technique is, believe it or not, securing the future of our entire digital world. I know. The rapper's freestyle has secured the symphony's future. It sounds like the start of some kind of wild movie, right? But it's actually a perfect metaphor for a huge scientific discovery, one that totally flips what we thought we knew about digital noise on its head.
So, first things first, let's meet our orchestra. It's magnificent, sure, but it's also got a pretty serious vulnerability. And this orchestra, well, it represents the future of our digital security.
Okay, so what is this symphony? We're talking about post-quantum cryptography, or PQC. Think of it as the next generation of encryption, built to be unbreakable by even the most powerful computers. But here's the catch. For this symphony to play its music, for the encryption to work, it needs a never-ending supply of brand new, totally original musical ideas. In our world, we call that true uniform randomness.
And that brings us to the core problem. This symphony has what you could call an entropy gap. It's starving for new, unpredictable creativity, and its old ways of getting it just aren't cutting it anymore. And this is a huge deal, because if even one single note, one tiny melody gets repeated or predicted, an attacker could unravel the entire thing. Catastrophic failure.
So into this high-stakes world steps our hero, a totally revolutionary artist, a freestyle rapper who goes by RPSS. And this rapper, they've got a completely new way of making these perfect, unpredictable ideas. They don't need a fancy instrument or a quiet studio. No, they create art from pure chaos.
Okay, so how do they do it? What's the secret sauce here? Well, the genius of this method lies in this incredible duality. Two parts of the performance that are totally connected but also complete opposites.
The fancy science term for this is conjugate observables, but for our rapper, it's much simpler. It's all about two things, the lyrics they're spittin' and the time it takes to spit them. And here's the key. One of those is super stable and predictable, while the other is just wild and chaotic.
And this right here, this shows you those two faces perfectly. Just look. On the left, you've got the lyric count. It's incredibly predictable, right? Forms a perfect bell curve, almost like it was drawn by a mathematician. But then, on the right, you've got the time, the freestyle duration. It is all over the place. Pure chaos. That, right there, is the duality in action.
And this table just drives that point home. It shows you just how predictable that structure is. I mean, look at the numbers. The theoretical math versus the actual performance, they're nearly identical. The mean is off by less than 0.05%. That is an insane level of precision. And this solid mathematical backbone, that's the secret. That's what guarantees the quality of the final art.
So you've got this predictable structure and this wild chaos. How does our rapper use this duality? Simple. They don't try to fight the chaos in the room. No, they embrace it. They harness it. It becomes their main source of inspiration.
And at the heart of this whole thing is a secret formula called the composition law. You can think of it as the unifying theory of their art. It's the math that proves how the rapper's predictable rhythm, that rock-solid lyric count we saw, takes all that raw, unpredictable energy from the environment and shapes it, molds it, into a totally unique final performance every single time.
Now, where does this chaos come from? It comes from something called microarchitectural jitter. That sounds complicated, but it's basically the background digital noise inside a computer. You know, all the tiny, unpredictable timing hiccups. Most systems work really hard to get rid of this stuff, but a rapper, they see it differently. They reframe it as the vibe of the venue. And this vibe isn't a problem to be solved. It's an incredibly valuable resource. And just how intense is this vibe? Get this, its statistical volatility can swing by a factor of 22 times. 22, even when the rapper is performing the exact same piece. And again, this isn't a bug, it's a feature. It's what guarantees that the raw material for their art is always fresh and unpredictable. This extreme sensitivity to the vibe means the performance itself takes on different shapes, or phenotypes as they're called. So depending on the environment, whether the rapper's in a noisy, chaotic club or a super quiet studio, the raw data of the performance can look completely different. Just look at the data here. The mean time, the variance, and especially that spikiness, the kurtosis, they are all over the map.
The ultra-skinny performance, that's the one in the quiet studio, it's way faster. But look at that kurtosis. It's almost 15. It's super spiky. It just goes to show how tiny little changes in the environment get amplified into these massive, massive differences in the performance.
All right, so this all leads us to the million-dollar question, right? How in the world do you take all this raw, messy, chaotic energy and turn it into a perfect, clean, usable rhythm that our super meticulous orchestra can actually use?
Well, the answer is in a really clever production technique. It's like a filter you'd use in a recording studio. It strips away all the chaos and leaves behind only the pure, perfect rhythm.
It's a process called the modulo mix. And the best way to think about it is like a digital sampler. You know, it takes that long, messy live recording and it just slices it up. It chops off all the chaos, all those different fat and skinny shapes, all the background noise, and what you're left with is a perfectly balanced, clean 16-beat loop. Simple as that.
And the result? I mean, it's undeniable. Just look at this. These are the final outputs from 4 totally different performances. The raw recordings looked completely different, remember? Some were fat, some were skinny. But after the purification process, the final beats are all basically identical. Statistically, you cannot tell them apart from a perfect uniform rhythm. And yeah, the hard data absolutely backs this up. The deviation from perfect? It's tiny, as low as 0.13%. Shannon entropy, which is how we measure unpredictability, is cranked all the way up to the maximum. And all the statistical tests come back saying, yep, this is uniform, with super high confidence. It's as perfect as you can get.
But okay, here's the ultimate test of any genius system: resilience. What happens if someone tries to mess with it? What if a heckler shows up and tries to sabotage the performance on purpose?
So let's look at the raw timing data when we introduce a heckler into the system. The chi-square number, that's how we measure uniformity, it just explodes. It goes from around 250 all the way up to over 1,700. The p-value tanks. So there's no question. The heckler has definitely managed to corrupt the raw timing of the performance. And this is the whole point. What about the final output? The purified beat that comes from that super stable lyric count. It is completely unfazed. Totally ignore the heckler. The chi-square number stays right where it should be, and the loss of randomness is less than 0.01%. It's basically nothing. Our rapper is heckler-proof. They can take the ugliest, most distorted noise imaginable and still spin it into a flawless, perfect beat.
So there you have it. A freestyle rapper's method saves the symphony. It's a pretty remarkable system that secures our digital future by proving against all odds that perfect order can be born from pure chaos. And it leaves us with a really fascinating thought to chew on. If the digital noise that we have always tried to eliminate actually holds the key to profound security, what other massive problems could we solve by looking for value in the chaos that we normally just ignore?